Hey there, DIY enthusiasts! Today, we're tackling a fundamental skill driving screws with a drill. Whether you're a seasoned pro or just starting, mastering this technique is crucial for successful home projects. A drill is an indispensable tool for countless tasks, from assembling furniture to tackling complex repairs. By learning to use it effectively, you'll save time, avoid frustration, and achieve professional-looking results. Let's dive in and empower you to become a screw driving expert. Next up, we'll explore the different types of drills you'll encounter. Get ready to expand your tool knowledge. Before we start driving screws, let's familiarize ourselves with the three main types of drills: corded, cordless, and impact drivers. Corded drills are powerful and reliable, drawing their energy directly from an electrical outlet. Cordless drills offer portability and freedom of movement thanks to their rechargeable batteries. Finally, impact drivers are specifically designed for heavy-duty screw driving, delivering powerful rotational force. Each drill type has its pros and cons, making them suitable for different projects. We'll delve deeper into selecting the right drill later on. Now that you know the players, let's explore the key features that empower these tools. Understanding your drill's features is essential for achieving optimal results. Two crucial aspects are torque settings and drill modes. Torque refers to the rotational force the drill applies. Higher torque translates to more power, ideal for driving large screws or working with dense materials. Most drills have adjustable torque settings, allowing you to control the power output. Drill modes determine the drill's primary function. Drilling mode is for creating holes, while screw driving mode optimizes the drill for driving screws. This mode typically features a clutch that disengages the drive when the screw is fully seated, preventing over-tightening. Next, we'll match the right drill to your project needs. Selecting the appropriate drill depends on the task at hand. Consider the project's scope, materials involved, and required power. For light-duty tasks like assembling furniture or hanging pictures, a cordless drill with adjustable torque settings is a versatile choice. For heavier projects involving larger screws or dense materials, a corded drill or impact driver provides the necessary power. When working with delicate materials or driving small screws, opt for a drill with a low torque setting to avoid damage. Conversely, larger screws and demanding materials call for higher torque. Now that you're familiar with drill selection, let's move on to another critical element: screws. Screw selection. Finding the perfect match. Choosing the right screw is just as important as using the right drill. The correct screw ensures the stability and durability of your project. Screws come in various materials, lengths, and head types, each suited for specific applications. Understanding these differences can make or break your project. For general woodworking projects, standard wood screws are a reliable choice. They are designed to provide a strong hold in wood without splitting the material. For outdoor projects or moist environments, opt for corrosion-resistant screws like stainless steel or galvanized steel. These screws are designed to withstand the elements and prevent rust. Screw length is crucial for ensuring a secure hold. The length of the screw should be appropriate for the thickness of the materials being joined. The screw should be long enough to penetrate the material being fastened and anchor firmly into the underlying structure. This ensures a strong and lasting connection. Finally, consider the screw head type. The head type affects how the screw is driven and how it sits in the material. Phillips and slotted heads are common, and they are easy to use with standard screwdrivers, while square and star-shaped drives offer better grip and reduce cam out. These types are especially useful for projects requiring a lot of torque. With the right screws in hand, let's explore how to choose the perfect drill bit for the job. The right combination of screw and drill bit will ensure your project is both strong and professional looking. Drill bits, the key to a secure drive. Drill bits are essential accessories that create a pilot hole for the screw and ensure a clean, secure drive. Choosing the correct bit is vital for preventing damage and achieving professional results. The most crucial factor is matching the drill bit size to the screw size. Using a bit that's too small will make driving the screw difficult, while a bit that's too large will create an oversized hole, compromising the screw's holding power. Additionally, ensure the drill bit type matches the screw head type. Using a Phillips bit with a slotted screw head or vice versa will result in slippage and potential damage to the screw head. In the next section, we'll discuss a crucial technique: pre-drilling. Pre-drilling preventing splits and frustration. Pre-drilling involves creating a pilot hole before driving the screw, especially when working with wood. This simple step offers numerous benefits, including preventing splitting. Pre-drilling relieves stress on the wood fibers, significantly reducing the risk of splitting, especially near edges. Easing screw insertion. The pilot hole guides the screw, making it easier to start and drive straight. Reducing torque requirements. Pre-drilling reduces the force needed to drive the screw, minimizing the risk of stripping the screw head or damaging the material. When pre-drilling, select a bit slightly smaller than the screw's shank diameter. Drill a hole deep enough to accommodate the screw's length without going all the way through the material. Now that we've covered pre-drilling, let's move on to ensuring accurate screw placement. Measuring and marking precision placement. Accurate screw placement is crucial for achieving a clean, professional finish and ensuring the structural integrity of your project. Take the time to measure and mark your screw locations carefully. Use a tape measure ruler or combination square to determine the exact position for each screw. Mark the spot with a pencil, awl, or center punch. When marking, consider the screw head size and ensure adequate clearance for driving the screw without obstructing adjacent components. Next, we'll explore how to adjust the drill's torque setting for optimal screw driving. Setting the torque. Avoiding stripped screws. The drill's torque setting determines the rotational force applied when driving screws. Setting the appropriate torque is crucial for preventing stripped screw heads and achieving a flush finish. Start with a lower torque setting and gradually increase it as needed. When the clutch engages, you'll feel the drill become easier to handle. This indicates that the screw is fully seated. Different materials and screw sizes require different torque settings. Experiment with scrap material to find the optimal setting for your project. Now let's put it all together and learn the proper technique for driving screws. Driving the screw, a step-by-step guide. With the right drill, screw, bit, and pre-drilled hole, you're ready to drive the screw. Having the correct tools is essential for a successful project. Make sure you have a drill that fits comfortably in your hand, the appropriate screws for your material, and drill bits that match the size of your screws. Follow these steps for a smooth and successful drive. Preparation is key. Ensure your workspace is clean and well lit, and that you have all your tools within reach. 1. Position the drill. Hold the drill firmly with both hands, ensuring the bit is perpendicular to the material's surface. This helps in maintaining control and accuracy. 2. Start slowly. Begin drilling at a slow speed, applying gentle pressure to keep the bit engaged. Starting slowly prevents the bit from slipping and ensures a clean entry point. 3. Increase speed. Once the screw bites into the material, gradually increase the drill speed while maintaining steady pressure. This helps the screw to drive in smoothly without stripping the head. 4. Ease up. As the screw nears its final position, ease up on the pressure to avoid over-tightening and damaging the material. Over-tightening can cause the material to crack or the screw to strip. 5. Listen for the clutch. If your drill has a clutch, listen for it to engage, indicating the screw is fully seated. The clutch helps prevent overdriving the screw and ensures a consistent finish. In the final section, we'll share tips for achieving a flush finish and recap the key takeaways. A flush finish not only looks professional but also ensures the structural integrity of your project. Remember, practice makes perfect, so don't be afraid to take your time and get it right. Tips for a flush finish and beyond. To achieve a flush finish, use a countersinking bit to create a shallow recess for the screw head. This ensures that the screw sits below the surface of the wood, giving your project a clean and professional look. It's especially useful for projects where aesthetics are important, like furniture or cabinetry. If a screw head becomes stripped, try using a rubber band or a piece of steel wool for added grip. Place the rubber band over the screw head, then insert the screwdriver and turn slowly. This trick can save you from having to drill out the screw and potentially damaging your project. Always wear safety glasses when operating power tools to protect your eyes from flying debris. Safety glasses are a simple yet crucial piece of protective gear that can prevent serious injuries. Practice makes perfect, so don't be discouraged if you don't get it right the first time. Start with simple projects and gradually work your way up to more complex tasks. This approach helps build your confidence and skills incrementally. For example, begin with a basic shelf or a small table before attempting larger furniture pieces or home renovations. Mastering the art of driving screws with a drill takes time and practice. Begin by practicing on scrap wood to get a feel for the tool and how it handles. Pay attention to the pressure you apply and the speed of the drill to avoid stripping screws or damaging the material. By understanding the different types of drills, screws and bits and following the proper techniques, you'll be well on your way to tackling any DIY project with confidence. Each type of drill bit is designed for a specific purpose, so knowing which one to use can make a big difference in the outcome of your project. Remember, safety is paramount when using power tools. Always be aware of your surroundings and keep your workspace clean to avoid accidents. A clutter-free area allows you to move freely and reduces the risk of tripping or knocking over tools. Always wear appropriate safety gear and follow the manufacturer's instructions. This includes not only safety glasses but also gloves, ear protection, and dust masks when necessary. Reading the manual helps you understand the tool's capabilities and limitations, ensuring you use it correctly. Stay tuned for more handy tips and tricks, including advanced drilling techniques and tool maintenance. Keeping your tools in good condition not only extends their lifespan but also ensures they perform optimally, making your DIY projects smoother and more enjoyable.